better. And then I think the Lord still missing that she was thinking. It's not mine. But you, I see where you got it. Just think that through again, it'll be like that last one, I think you did it. Oh, good. So if you ended up with the usual right there. Oh, good. So these are a couple, I know it looks messy, but it does for you for having something. Good job. I'm doing you. Start on one. Oh, that's a good idea. So I don't think about that. Oh, she's going way before the size you got. That's hilarious. You have your mom supervise. Yeah. Good. Good. What else can you see? What does it mean? Two. Yeah, but it's in the four. If you pick two, you could just cancel it in, you'll be okay. This is central right here, because those are just what you couldn't see, you know, something's going on your door. Good job. You think so? Check under your shoulder. Okay. She showed us to your mom. You have done such a good job. Alright, now if you divide this one by two, we have to do this one. This one's here, right? So what's going on the top? I don't think I have an eraser, but you do it. Yeah, because you divide this one by two, and you divide this one by two, but I'm not the same thing. Alright, yeah. What would you have to do is when you get this, or whatever you find out, that's what you're gonna do. Alright. Figure it out, huh? Can you still do it? That's good. You remember. Good job. Yes. Alright, it's been about 15 minutes. Let's just stop there. Put your pencil down. You can pick it back up if you need to fix something or if you need to finish something. Okay, but let's go ahead and do it. Anybody want to do one? David, go do one.
So I do the first one? Yes.
Go do it. Go ahead and do it. You don't have to. I'm not going to make anybody do it. But if there's one you're like, no, I feel confident about that one, then you're welcome to go do it.
Well, 7 could be the same as 6 and 3 phones. And then we just do a simple subtraction problem. Which should.
Good. There you go. Put your, now, will you circle the 4 2/3? Just so we can see this. Perfectly done. Good job. Everybody give an hand. Good job. You can hand the pen off to whoever would like to do 2. All right, Christine's got 2.
So, 2, you can just go 4, you can change it into a 4, and 7, 6, 1.
Well done. Circle the last one for me. Good job, Mr. Palmore. All right, number 3. Who wants to do it? This is the one that everybody seemed to struggle with. You want to do it? This one was a tough one. Go for it. This one, every single person I had a comment for them when I came through, I think. So it's okay. This one's still a little tough. All right, go slow, David, so we can process. Okay? What's going to cancel?
I'm gonna first one and cancel the 10 and 5. This is a 1. It's a 2. And then the 9 and 12 divided by 3. 3, 6, 9, 12. So that would be 3. I don't know what that's what we cancel.
You're
I could have
You can just
That's okay. Leave it like that. You can cancel again here in just a second. You can go with the 8 and the 2, and the 3 and the 5, or the 8 and the 4 if you want. That's okay. Yeah.
Just 1.
Yeah. It doesn't matter.
I'm gonna cancel both of these.
Very good.
1. 3 and the 15. That should be 5.
Uh-huh.
1.
Good.
And then this is 1. And that's 5.
Good job. Well done, Mr. Stockdale. Oh yeah, you gotta circle it. All right. Really well done. I want you to know though, everybody had trouble with that one because there's just so much to cancel. Okay, as long as you're canceling top to bottom, you're good to go. Even if it was a cancel number. All right. Anybody with 4? Anybody want to explain 4? You want to see Christian? Here you go.
So a square has to be divided into, after all have the same side, so 1 yard is 3 feet. So technically 36 inches. So you do, I did this, well, it goes into it 9 times.
Good.
So I did 9 inches on each side. And just multiply these.
Because your area is length times width, right? So 9 times 9. Very good. Now let's see if he gets his units. Pressure's on.
Oh, wait a minute, did you mean 9? That's all right,
I
I
mean,
distracted you when you were writing. That was my fault. You were thinking about your units, I messed you up. Sorry, Mr. Calhoun. All right, good job. Oh, circle it. You got David for circling. Okay, anybody want to do 5?
It's so weird because I was like literally just focusing on circling everything on
I know.
my test. So,
I think Eli will do it. Yes, this looks like an Eli problem. You did great with helping me last week. You sure you don't want to do it? Look at me. He's going to do it. Mr. Lingerfeld is approaching the Lord. Be a nice teacher
I
now.
didn't even notice what we did.
Oh, you didn't? Yeah, we didn't. Well, Canyon's not here, so hey, Canyon.
I know.
Okay, go for it. Good. So you wrote 24 over 22. And he's changing it to a mixed number. You don't have to erase it, you just write beside it. Oh, I see, you're writing it. So he's got 1 and 2 over 22. And then what do you do at the very end? They're both even. So what will go into both of them? One will go into anything, you're right. Go up one more.
2.
2, they're even. Anything that's even, you can divide it by 2. So divide them both by 2, and you'll have 1 and
so
something.
just cut them in half.
11.
1 and, yes, something over 11. Yes, 1 and 1 11. Well then now, you know what makes this even more impressive? He got in here a little bit later and didn't even get a chance to work this problem. So he did that one on the fly in front of y'all. Well done, well done. He did that very well, okay? This pen is not always easy to use, is it either? When you get up here, sometimes you turn it one way and one. All right, girls, what do y'all want to do this one? Okay, you are bad at these, but you got it right.
Should I copy my work?
You can certainly copy your work. Go for it.
Well, actually, I don't. Oh, copy.
Okay.
Never mind.
Why don't you both go together? You can take the dog with you.
Come on, no.
Yeah, go with her, right? You can take the dog.
Take my notebook so we can copy my work. I already know how to do that. I can't copy.
That's all right. Oh, wait, I think you. No wonder, that's really hard. Oh, wait, we can't hear you. What'd you say?
She's lovely. I'm going.
I'm sorry, I was talking while you're talking. Please don't be mad at me, teacher.
I don't know. 16. Yeah.
All right, so do the last step, Lily. She said, I know you gotta do 3 times 16 to get 48. She's right.
I have no idea what she's doing.
Well, she just did.
She's multiplying 3 times.
Well, but how do you find that? How do you find 16? Do you know your 16 facts? Because that's impressive if you know your 16
I did
facts.
on my paper.
That's okay. She probably
She
divided
started
it,
it and
didn't
then
she?
she expected me to
Yes.
straight.
Yeah, that's what she did. So she did this number divided by this number and found out you're gonna have to multiply it by 16 to get this. So you gotta multiply this one by 16 and Lily finished it. Perfect.
But
Y'all did audience math.
Nobody told me.
Good job, y'all.
So painful.
Ah, see? But see now it's better than y'all having to sit the whole time. What did I do with the eraser? Did y'all see my eraser? Oh, it's under. Come on. All right, how about everybody stand up and stretch for a minute before you sit down? Okay, so I want to say while you're stretching, so don't stretch your mouth, just stretch your leg muscles, I guess, and your arms. So, I want to say I'm really impressed by what I saw there because just a few weeks ago, the fractions were really, really hard. So this shows me y'all are practicing those and you're getting better at it, and that's really good. So I'm going to clap for all of y'all because y'all did a really good job on that, okay? Really, really, I'm pleased with that. All right, so today we're going to start with the next lessons. We're going to talk about triangles for a minute, so don't write this down, just think. Can y'all think for a second? Ready? All right, if I draw a triangle, okay, there's my triangle. Do you know anything about the measures of the inside of a triangle? Like if I measured all those angles, Christian, what do you know about it?
Is that it can be found out in degrees?
Yes, we're measuring in degrees, that's right. Do you know how, well, let me start back with this. How many degrees, if you think about your protractor, is a straight line?
180.
It's 180. This is 180 degrees, okay? So what about the number of degrees in a triangle? It's not 360, that's a circle. It's not 90.
360?
I'm gonna take what Josiah said. He said 90. Let's draw a 90-degree angle. Okay, a 90-degree angle, we would put that in there. There's a 90 degree.
It is less than that.
Okay, it was not less than that.
It's more.
Because it's gonna have to be more, because if you can have a right triangle, if you can have a right triangle that has a 90-degree angle in it, it's got to be more than 90. But Josiah gave us a good starting point. So, not 100. Believe it or not, y'all are going to need to do this when you go home, and it's actually in this week's lesson. If you do the little construction, and you should, that's in your book, it will prove to you that it's 180 degrees. So let me show you on the board what you're going to do at home. Oh, I'm sorry.
Yeah, I said
heard
180 degrees.
I'm sorry, I missed that. All right, so if you draw any triangle, whether it's a right triangle, or whether it's an acute triangle, or an obtuse triangle, any kind of triangle, draw it on paper with a ruler, okay? Don't just freehand it like I did. Draw with a ruler, cut off the tips. The vertices, like literally cut that off, and cut that off. And if you place them next to each other, it'll form a straight line. No matter how big the triangle, no matter how small the triangle, it'll always work. Any triangle, the degrees of the internal angles is 180 degrees. And that's a pretty important thing to be able to know because of some things that you're going to be doing. So let's see. There's some other angle stuff we're going to do. Let's write this one down. Okay, I'm going to go over here to the side so we can keep looking at that. This is example 1. This is lesson 40. Y'all writing? It's awfully quiet back here. Example 1. I'm going to draw a picture, and y'all draw this picture too. It's like Josiah's right triangle that he was talking about a minute ago. You draw that. And put a box in the corner, which shows that it is a 90-degree angle. Put an A up here, a B here, and a C here. Okay, this is triangle ABC. Now, they may tell you to find the measure. See this little M? That often means the measure. What does this mean?
The angle.
Angle of angle A. Okay, find the measure of angle A. Well, there's no way to know. I do know it's got to be less than 90 degrees because you can't have two 90-degree angles in a triangle. It's not possible, right? Because if you have one 90-degree angle and then you make another 90-degree angle, you can't close it and get a triangle. It's going to be a quadrilateral, isn't it? Okay? So we know that this has to be less than 90. It's going to have to be an acute angle. But they tell you in the book, they give you one more piece of information. Go back to your picture and put a 30 degrees at angle B. Now write down what you think angle A must measure. Write it on your paper, don't say it. So if we know this one's 90, then these two have to add up to what? 90. Because look, if we know the whole thing, all three of these equal 180, then if this is 90, these two have to equal 90. Well, what would this one have to be for this to be the total of 90
degrees?
It's going to have to be 60 degrees. Okay, how many people said 60 degrees already? Okay, if you didn't know, it's okay, because now you do, right? So, if you add all of them together, 90 and 60 and 30, you get 180 degrees. So if they give you a triangle and they tell you 2 of the angles, all you have to do is find the third angle, okay? And that's one part of this lesson. Another part of this lesson, so here's example, does it say example 2? Sort of with example 2. Yeah, we'll do it with it, okay? This is example 2, part of it. I want you to draw a line like this, and then I want you to draw a line like this, and I want you to put arrows on the ends of them. Those are 2 intersecting lines, okay? I want you to call this in here 1, this angle. This one's 2, this one's 3, and this one's 4. Okay, there's some terminology that you have to know here, and it's in your book, so I don't think you necessarily have to put it in your notes because you're going to have your book to refer to, but I'm going to write it on the board just so you can see how you spell the word and what I'm saying. Adjacent. Have you ever heard of that term? Not in math, but just in life. Adjacent. Like I parked adjacent to Ingalls. Parked next to it. Okay, adjacent just means next to. So adjacent angles here would be angle 1 and 2. They're right next to each other. Okay? What are some other angles that are adjacent?
3 and 4.
3 and 4. What's another?
4 and 1.
4 and 1.
3 and 2.
2 and 3 or 3 and 2. Okay? The other thing that they're going to tell you about, I think, in here is vertical angles. Okay?
2 and 4, 1 and 3.
2 and 4, that means they're opposite of each other. Okay? Not side by side. So adjacent is side by side. Okay? Vertical is straight across from each other. So 2 and 4, 1 and 3. The other thing they're going to tell you about, and I bet you've had this word before. Yeah, have y'all heard of supplementary? Supplementary angles. And then, I don't have it up here, but I'll show you another one in a minute of complementary angles. But supplementary angles add up to 180 degrees. Do you see any supplementary angles? Well, a line is 180 degrees, right? So if I took and started here, look here, this angle plus going the rest of the way to here makes one straight line. So angle 1 and 2 are supplementary. Angle 2 and 3 are supplementary. Angle 3 and 4 are supplementary. And angle 1 and 4 are supplementary. That add up to 180 degrees. Whenever you add them, you get 180 degrees, which is just a straight line. Okay? There's one more thing that they give you, and they call it complementary. You heard that word before? Yes. Maybe not with math, right? Complementary angles are angles that when you add them up, and I'll see if you can tell by the picture. Yes. So this little angle in here, we'll call it 5 and 6. Angles 5 and 6 are complementary. They add up to 90 degrees. Okay, this is all in your book, but just so you can kind of see, they're going to be using these words. They'll give you some sort of picture, and they'll say, give me angles that are adjacent. Give me angles that are vertical. Give me angles that are supplementary. We don't have any complementary angles here. How come?
Because they don't add up to 90.
There's nothing here that's 90. But here we have, these two angles are going to have to add up to 90 degrees, like the one we had earlier. These are complementary, okay? They add up to 90. All right, let me give you this drawing, and I guess this is really the book's example, too. It's going to be easier to draw if you draw it with me. So draw the side of a triangle, and then a line going straight out. And then from the top of the triangle, come down, and you leave like a little crossing point there. And draw arrows on those ends. Okay? This is going to be a right angle. I'm going to tell you that this angle is 50 degrees. So now you know two angles. I'm going to tell you this one's X, this one's Y, and this one's Z. Okay? Can you figure out all of the other angles? I'm going to give you a minute to try it. You may be able to find one, and then after you find one, Anybody got a thought on where to start?
Is this top part an angle? Right here?
Is this part, it's supposed to be a line.
Yeah.
I'm kind of curved. It
No,
shouldn't
but
be.
I meant like why?
Yeah, that's
That
an
one.
angle.
Okay.
Yes, that's an angle. Anybody got an idea of where to start? All right, Christian, just tell me one thing of good starting point.
X, to find, the 90 degrees, to make it 90 degrees.
Good.
Plus 40.
Very good. So he saw that this was a right angle, so this triangle's already got 90 in it. So these two better add up to 90, because that's gonna make 180, right? So 50 plus what would give me 90, it'd be 40, right? So I'm gonna write that in, and then Eli, do you have another place where we can go once we have that
I'm
40?
just saying though, you could, and then if you have any missing an angle, you could just subtract the number from 90 degrees.
Yes, you are exactly right. If it's a right triangle, yes, you are exactly right. And if it wasn't a right triangle, you could just add those two up and then subtract that from 180, right? Instead of 90. Very good. So what else can I do now? I got one little piece of information. What else do you see? Give him a second, because Christian sees something. See if you see what he sees. Think about supplementary angles, and then you can think about vertical angles. What do you see up there? You could go either way here. There's a pair of vertical angles. Look up here. What angles are vertical here?
40 and, X and Z.
X and Z. I didn't tell you that there's a special relationship with vertical angles, but I'll tell you that in just a second. Josiah?
Will Z be 40 degrees?
It will, because vertical angles are always equal. And I didn't tell you that, but I will now. But there's another way, another direction we could have gone, and that's supplementary. Look at the relationship between X and Y. They should add up to what?
To 180.
Yeah, X plus Y should be equal to 180 because they form a straight line.
So 180 divided by 40, so.
And also,
Why do you want to be 40?
Yes, that's exactly right, because if 40 plus something is 180, that something has to be 140 degrees. I actually like these problems. This is a really common kind of SAT test prep problem where they give you something and you have to know supplementary angles, vertical angles, all of that to be able to figure it out. Christian?
I also did I just remembered off my protractor, when we did angles, how the top ones, where it kind of went into the hundreds, and then there was tens on the bottom, and I just found that 40 was matched up with 100.
Very good. So that's a good point. On the protractor, that it shows the supplementary angles, doesn't it? Yeah, that's a good point. All right, example 3 is about a parallelogram. I am going to try to draw it up here. This is still lesson 40. And we're still kind of talking about these relationships, but there's one other type of relationship. And y'all might have never had this before, and if you haven't, don't stress about it. It's just going to take a minute to learn it. Everybody, when they first learn it, just takes a little bit. All right, I want us to draw a parallelogram. So a parallelogram is just a four-sided figure with opposite sides are parallel. A rectangle is a parallelogram. Okay, it's just a special one because it has all 90-degree angles in it. All right, I want you to name it. I want to put an A in the top right corner, and I want to put a B in the bottom right, a C bottom left, and a D on the top left. Then I want you to cut it in half. Here I go get dividing again. There we go. Cut it in half going down to the middle.
What
Okay.
page is this?
Yeah, I don't know. 275. This is a PG 275. Dave.
Oh, no.
All right, this is 60 degrees at C. And then I want you to put a 40 degrees over here, but I'm not going to call that B. How come?
Because the angle is different.
Yeah, because B is actually this
Is up
plus
top.
this, isn't it? But this is C, okay? Now, there's some stuff in your book. I'm going to read to you what it says about parallelograms. Let me see. Okay, segment BD. I'm not going to have you write this. I'll just read it to you. Segment BD, that's a line segment. It's a piece of a line. Divides the parallelogram into two congruent triangles. What's congruent mean?
Exactly the same.
Yes, it's kind of like in math, an equal sign talks about numbers, values are equal. But in geometry, congruent means they're the same size, same shape. There's kind of like the equal for geometry, okay? All right, then it says, angle CBD is 40 degrees. Which other angle measures 40 degrees? All right, I'm going to read to you how the book explains this, and we're going to talk about it. A segment that passes through a polygon, that's just a multi-sided figure, to connect two vertices is called a diagonal. Y'all say diagonal. You're familiar with this when you buy TVs. The measurement of the TV is the diagonal, isn't it? That's how they measure them. A diagonal divides any parallelogram into two congruent triangles. That's another tidbit of information you have to know to do this lesson. Segment BD is a diagonal. So that means these two triangles are equal, okay? But we know that this one and this one, look at the shape of them. In a parallelogram, we've got this one kind of squished that way, and this one is squished that way. Notice how this one and this one are your acute angles, right? And this one are your what? It's not acute and it's not right. Obtuse. Those are obtuse angles. So what you kind of have to do is imagine cutting this and spinning it around. Okay, so I'm going to try to draw it from here to where if I spin that around, this is now B up here, this is D over here, and this is A. Okay, so let's go ahead and look at how they compare. That means that A has the same measure as what?
C.
C. Going to have a 60-degree measurement. Okay, that means that this at B is going to have the same measurement as which one?
On that one,
Yeah.
it would be D.
Yeah, that one's going to be, so that's going to be what, 40 degrees?
Yes.
Here. Okay, and then that's kind of a tricky thing because you haven't learned all the vocabulary yet, but it's at the end of the lesson after you've had a chance to kind of practice some of the other stuff. So when you read it, I think it'll be fun.
to figure out the other ones?
Well, we could. How would we find it?
Subtract 180.
Yeah, so this is like what Eli was talking about a minute ago. We don't have a right triangle, right? They're not telling us it's right, but I add those two up and what do I get?
180.
Yeah, I get 100 here. Take that away from 180, that one's got to be 80. Right, good job. All right, stand up and stretch, and then we're going to do 40, the next one, whatever the next one.
PG. PG.
All right, the next one is investigation 4. Have y'all ever done box and whisker plots?
Yes.
Yes? Okay, so let's see. I don't know how well this will work, but we're going to make a mini box and whisker plot. Okay? So I'm trying to think of, all right, everybody think about your birthday. Okay? Mine is the day, the dates of the month. Mine is on the 25th. Josiah, what day of the month is yours on? Not what month, what day of the month? 28. And David?
29.
Oh, this will be nice. Eli?
17.
4.
Oh,
24.
wow, that's exciting.
31st.
Okay. All right, so we have a lot of different days of the month. Now, to organize this, we could do maybe a bar graph and put each of these and put how many people. We could even put down here how many people have in the 20s, how many are in the teens, how many are in the 30s, right? And put a number above it. We could do a table. There's lots of different ways of organizing numbers, right? But this we're going to do is a box and whisker plot. Okay, this is something else that they love to put on standardized tests. All right, so to make a box and whisker plot, you notice that a lot of these have 20s, okay? I've got a 1 that has a 1 in the tens digit. This one has what in the tens digit?
0.
A 0, and then we've got this one that's a 3, okay? All right, so the way you do a box and whisker plot, or I'm sorry, I keep saying box and whisker. We're gonna do that second. Let's do a stem and leaf first, because that's how the book does it. A stem and leaf plot. And what does that sound like?
I have no idea.
A plant.
A plant. So let's think about a plant for a second. Okay, you got a stem that comes up out of the ground, and then what comes off the side of it?
These.
A leaf. This is a dead plant because it's not pretty and green. It's all right.
A black.
We've got, this is not in water, but that's okay. All right, it looks nice though. It looks nice. So a stem and leaf plot is going to have a stem with something coming out from it. So here's your stem. Okay, you don't have to draw it yourself. You can watch. I need a 0 as a tens digit, a 1 as a tens digit, a 2, and a 3. Okay. So instead of writing all the numbers, they pick one digit to put as the stem, and then the other digit to put off as the leaf. Now, what number goes with 0 as a tens digit? The 4. I'm going to check it off. This would represent the number 4. It'll make more sense as we go. The tens digit of a 1 is a 17, so I put a 7 there. That represents 17. This is where it'll make more sense. Let's look at the 2s. Which is the smallest one with a 2?
4. 24.
All right, 24. So what will I write?
4.
Just 4, but I'm going to put a comma because I have some more to do. The next one's 25th. The next one's 28th.
29.
And the next one's 29th. And then I have a 31st. Okay, so that is our stem and leaf plot of our dates. It's kind of weird looking, isn't it? It's a weird looking way of organizing data. Okay, when I used to teach this in school, I had my students do a sports project, and I had them. This is statistics. If you've ever heard an older sibling or cousin or somebody talk about statistics, this is kind of introductory statistics.
Stats.
This is just a way to organize the data. Now, you may have a problem somewhere where they give you the chart like this, and they're like, well, what does this mean? Well, now you know this is just for 17, 24, 25, 28, 29, 31. So what can we do with this? So let's open your book on 279. Okay? 279. I'm not going to have you write this. I think it'll be beneficial just to read it, and then we can interpret it with our stem and leaf plot. All right, 279. You see their stem and leaf plot? Okay, what's the first number in their stem and leaf plot? Not just 1, 21. Good, good. What's the last number in their stem and leaf plot? 50. 58. 58. And they didn't put commas between them, did they? I always put commas between them, but maybe I'm not supposed to. I don't know.
That's confusing.
Yeah, that kind of, it looks weird, doesn't it? But now that we've made one, does it make more sense if you had just seen it without it? All right, let's turn the page. It has you look, the first purple word. What's the first bold purple word you see? Mode. Does anybody remember what mode means?
The
Was it? It was
average?
yeah.
It's not the average. It's the one you see
The most of it.
most. Mode is the one you see the most. For us, which one's the mode? There's not one. Yeah, there's not one because nobody had the same date.
So would you
Okay.
say about something?
You would just say it doesn't have one. Doesn't have one. So in their stem and leaf plot, let's see what their mode was. Well, actually, you will get to do that because that'll be homework. So we won't do that. But ours does not have a mode. What's the next purple word you see?
Range.
Range. Does anybody know what range is?
It's like the difference between like the least and greatest like number.
Good. And he said the difference, which is a subtraction from your biggest minus your smallest. So what would our range be? 31 is the biggest minus 4. So ours will be 31 minus 4, which is 27. That'd be our range. Okay? Now, think about our context. Could we have a range of 100 when you're talking about dates?
No.
Well, how many days does a month have?
30 to a
No more than 31, right? So you couldn't have a range. There's only a specific mark. It depends on what your data is, but for ours, this makes sense that our range would be like 20-something, 30, right? All right, what's the next purple word?
Medium.
Median. Have you ever heard that word?
Yes.
Where's the median when you're on the road?
The middle of the drive.
Yeah, the median is the middle. You don't want to drive on the median.
The middle.
Yeah, it's the middle number. So, how many numbers? 1, 2, 3, 4, 5, 6, 7. So the middle number will be which number?
70.
Well, no, I mean like in a list of 7.
Oh, it would be the.
It'd be the fourth one. 1, 2, 3 on either side, and the fourth one's the middle. So 1, 2, 3. 1, 2, 3. The middle is the 25th. Hey, that's me. So I am the median. Okay, so we would write 25 for the median. Does that make sense? The one that's in the middle. Okay.
It seems like a middle number.
It does. All right, and then it goes on from there and talks about quartiles. All right, let's look at that word because that sounds really weird. What does that remind you of?
A quarter.
Quarter. How many quarters are in a dollar? 4. Okay, so it's talking about dividing the data. When we found the median, we divided the data in half. But when you find the quartiles, you divide it in half and then in half again. Okay, so let's divide our data into half again. Okay, look at the top half. There's 1, 2, 3. What would be the middle of the top half? Say the 7. Yeah. And then the middle here would be the 9. So you would have your first quartile, your second quartile, your third quartile, and your fourth quartile. It just divides the data up into 4 parts instead of into 2 parts. Okay?
So it would be 7, 5, 9.
Yeah, and I think they actually, do they tell you here? I think they end up dividing it. Let me see how they did it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's how they did it. So that would be our first quartile. What does it say? The middle number of the lower half is the first quartile. And I think it asks you. Yeah, I don't think it actually asks you to do that. And then I think it just has you divide it into quartiles. So just as long as you remember quartile meaning 4, like what David said, and that's just dividing it in half, and then each of those halves in half. Does that make sense? Okay. You okay? Mm-hmm. Okay. All right, box and whisker plots. Go ahead and turn the page. You're thinking about looking at something weird. This one's weird too. Okay, if we did our data in a box and whisker plot.
Which page?
It's 282.
Oh, yeah.
Okay, y'all stay with me. 282. Yeah. Here's your number lines. We've got to start way down here at 4, and we've got to go all the way to 31, right? So I would probably go like, I'd probably do this. I'd probably say like 0, 10, yep, 20, 30, 40. All right, so then you would go through and you would mark where your data, what's your lowest data point? Ours. 4, so we'd say 4 is about right here. So I would go above that and I would point, because that's the lowest one. What was our upper?
It was 31.
31, so that would be here, right? Okay. And then where was my median?
25.
25, so it's going to be halfway in between here. Now, according to my thing, is it in the middle of this?
No.
And it's not necessarily going to be. It's in the middle of the data set, but notice our data has a whole bunch of 20s. Did y'all notice that? There's a whole bunch of 20s. So our median is in the middle of the data, but it's not going to be in the middle of the number line. Does that make sense?
Yes.
Okay, to me, I think that's a little confusing sometimes. And then where did we say our quartiles start? We got 7,
9.
not really 7, I said
17,
17 and 29. So we go to 17 and we go to 29, which would be, wait, was this 30? No, this is 30. So right here. So if you look at how they draw it, they put a line at the median, they put a line at this one and at this one, and then they draw a box. Okay? And then they draw these, and that's what the whiskers are. That's called a box and whisker plot. Y'all with me? Do you see the box? Do you see the whiskers? Like the little whiskers sticking out from the side. So if they gave you just a graph of this, if they just gave you a box and whisker plot, and that you would have to look at that and go, oh, the median is always this line. There's the median. There's your lowest value, there's your highest value, there's your quartiles, okay? I know a little bit confusing, but hopefully enough information that you can watch your video this week and you can read it and you'll be able to figure the rest of it out. How many of y'all have ever seen a stem and leaf plot before?
No.
Okay, 2 of you, okay? How many have ever seen a box and whisker plot?
No.
Just 1. Okay, so when you watch your video and you read this week, you'll get it. Hopefully that'll be enough to help you get started. All right, stand up to your hand.
It's getting a little very
Y'all don't need to stretch, just David. I need water.
things tight.
All right, this one's 41.
Yeah.
Okay. How far are we going? 42, I think.
We got about 20 minutes.
Yeah, we've got a little bit. We'll be good. Okay. Y'all know, I feel like this first one y'all can do this pretty easy. Do this one on your own. I think y'all can all do this. All right, if you know, what does this stand for? What's that stand for? You ever seen that before?
Length times width
Equals what?
equals the area.
Area. So area, it's a formula. It's a formula. And that's what half of this lesson is using formulas. If I told you to find the area of something, what would you have to know? You have to know the length and the width. So I'm going to give you the length and the width. The length is 8 feet and the width is 4 feet. Be careful with your units and go ahead and do this.
What? Oh, feet.
So we're talking about area. So we've got 8 feet times 4 feet. 8 times 4 is 32, but what's feet times feet?
Square.
Square feet, that's right. So hopefully you wrote down 32 square feet. If you didn't, throw your little exponent on your feet. Okay? All right, that's the first part. Okay, then there's one where they ask you to do one with perimeter. Okay, I'm going to get you to do. Let's review our perimeter formula. Just see if you can remember. What do you do?
Is this example 2?
Yes, this is going to be example 2. I'm going to draw a rectangle, and I'm going to label it length and width. Okay? Who can give me a formula for how to find, I'm not going to give you any numbers yet, a formula with variables for how to find the perimeter? All right, David?
Add all the edges together.
All right, so could I put length plus width plus width?
Yeah.
Would that be okay? Length plus width plus width. Could I simplify that?
Yes.
Just length and width.
No,
Well, no, that's area.
length plus width squared.
Okay, we're not multiplying them.
Well, no, length plus, like, you can do length plus width and then multiply it to get the perimeter.
I can multiply it, not by itself though. What am I multiplying by? 2. So I have, this is the same as saying I have 2 lengths plus 2 widths. Y'all with me? Did you write it? You got it? Okay. So you can just skip down to this one. That's 2 lengths plus 2 widths. Now, I'm sure there's at least one person in here who does not do it that way. I'm sure there's probably several that you don't do it that way. Can anybody think of a different way to do perimeter?
Length plus width times 2.
Okay, sometimes I do this. I'll add those 2 and then I double it because I know that the rest of it's there. So let's write it.
That's kind of what I meant, like,
Oh.
like in parentheses, sorry.
Oh, I got you. I thought you were saying square.
Yeah, like
Oh.
open parentheses,
Okay.
length, times length plus width and square outside.
Not square, but times 2.
Times 2.
Yes, this is square.
Yeah.
Right. I see what you're saying now. Alright, so this is one formula, but this is another formula.
I just add them all together.
Well, you can, but look, there's another point in showing you this. I want you to see something here. Both of those formulas are the same. You'll get the same answer if I gave you some numbers. You could do 2 lengths plus 2 widths, or you could do 2 of the length plus the width. Find that first and then double it. So look up here for a second. There's a property called the distributive property. I'm gonna write that word down. Y'all ever heard that word distribute?
Yes.
Okay, who distributes something? Can you think of something that is distributed? What? Mail. Perfect example. Perfect example. So you take the mail carrier takes the mail and distributes it to each house, right? You know how you get those grocery store sale papers? Everybody gets those, right? And so the mail carrier takes it, this house gets one, this house gets one, every single house. Doesn't skip a house, every single house. What if the house has had nobody that lives in it for 10 years? They still get it, okay? Every mailbox is gonna get it. So here's my point in that. You with me, Keela? Look right here. My point in that is saying, this is the distributive property. If you're gonna multiply what Christian said by 2, it's the same as multiplying each one of them by 2 and then adding them together. The distributive property says if I give you a problem like this, you can say, well, that's the same thing as just doubling both of them. Now, y'all may be looking at that right now going, okay, well, that makes sense. I don't understand why that's a thing. Well, let me give you a problem that may show you why it's a thing. Here's example 3. Okay? I want you to do 6 times 20 plus 5. Write that down. 6 times, in parentheses, 20 plus 5. According to order of operations, who can tell me what we should do first? All right, Josiah.
Add 20.
Good. So 6 or 20 and 5, yeah. So 20 and 5 is 25. All right, what would I do now?
Now you would multiply.
Good. Now 4 25s make what? 4 25s is 100. We just have 2 more. So that's 50, so 150. Okay, so we got the answer 150. I want to do it using the distributive problem. Write it again. I want you to write the same problem again. Okay? Write it again. Distributive property. Let's do it using the distributive property. This is the mail carrier. These are the houses on the street. See this number plus some other number. I've got to go to every single house and multiply it by 6.
6 times 20.
Alright, 6 times 20 is 120 plus
6 plus 5.
or 6 times 5, which is 30, and I get 150. Now, does that mean we don't have to worry about order of operations anymore?
No.
No. So what's the point? This is just easier to do. Why do we even need this? Well, let me show you. Don't write this down because I'm looking forward to algebra here. You're going to have a problem like this. And you're not going to know what x is. And you're going to have to be able to distribute it. But you know enough right now to do this. You know enough right now to do this. This just means double everything on the inside. So what's that?
2x.
Copy down the plus. What's that?
6.
2.
And that's how you're going to do it in algebra. That's one thing you'll learn in algebra. Yeah, that would be the answer.
Algebra's crazy.
Well,
that's not even like, that's like pre-algebra.
Yeah, you probably might be doing some of that later in the year, and maybe even a little bit later, I don't know. I didn't look that far ahead, but look, up here. You still do it order of operations. Still do it order of operations. I just need you to know that this, just like here, is another way of doing it, and there will be times when you will have to do it that way.
Like a 50.
Now, how are they going to do that in homework, okay? They're going to give you a problem like this, and they're going to say, work it 2 different ways. Or on the test, work it 2 different ways. You'll have to do your normal order of operations way, and then using the distributive property way, okay? All right, that's it for 41. and now we got 42. Now 42, I think is gonna be super easy. Everybody get up, walk the laps, go say hello to the puppies.
No.
They are, I can't believe how much they've grown. You think they like not go, oh, mama's coming, mama's like, wait a minute. Or maybe she saw that. And she's like, I'm gonna go and talk about it. They're so cute. Have y'all sold any yet?
Nope.
No.
Well, we also got this one.
You're what?
We also
Oh, you did already know. Yeah, I know you can't send them yet, because they still need mom. But I was just curious if you had already promised.
They can't speak. It's so sad.
Alright, y'all head back to your seat. Look at page 291. Just keeps getting worse and worse. 291. We got a couple minutes left. What do you got? Oh, it's not lesson 4. We are not going backwards. Thank you, Joe. 42. Let's don't go backwards. Y'all done a lot of work. That's a lot of work. All right, you ready? 42. Yeah. 291.
Oh,
What dog? Okay. All right. On 291, look at example 1. You don't have to write this, Christian. Open your book. We're almost there. 291. Y'all there? Look at example 1 on that page. We're not going to write them. I don't think y'all are going to need to write them. If we see something and y'all are like, hey, I've never done that before, I'll work it, but I don't think you need to write it. Look at A. Look at example 1A. Do you see it? 0.083333. What does the direction say, David? Read us the direction.
Rewrite each of these repeating decimals with a bar over the
Yes. Yes, I don't even know how to say that. I don't know. Yeah, that sounds good to me. David, do you know how to do it?
Well, you could just say, for the first one, just 0.083.
And yes, and you put a bar over the part that repeats. Does the 0 repeat? No. Does the 8 repeat? Does the 3 repeat?
Yes.
So you only put the bar over the 3. Have y'all done that before?
Yes.
Okay.
So like when we were doing like the formula like pi.
Yes. And pi has no repeating digits, does it? Look at B. Y'all look at B.
Oh, it's a pattern?
Yeah, there's a pattern.
So after the 4, would it be a 2?
No, it'd be a 1 over the 4.
Oh my, do y'all see the pattern?
Because the 4 is repeated. So
It's not just one number repeated on this one.
2857. No, it's 142857.
Yeah, look, 142857, 142857, and then they give us a 14 ... which means it keeps going, right? You'd have to put the bar over
this whole thing.
the whole thing that repeats. Then you wouldn't have to write this part. You would just erase that part and put the bar over just the part that repeats.
That's the most crazy decimal in the world.
Look at C. Where's the bar gonna go?
Over the
the
5-4.
Yeah, over the 5-4, because it's 5-4, 5-4, 5-4. So you're gonna put it over the 5 and the 4 after the decimal. We don't use these. Let's see. Oh, I wrote it wrong. That's right. We do not use them over whole numbers. We only use the repeating bar over decimal numbers. So it would be like this, and then you lose this part. Okay? Almost done. Almost done. Okay, y'all understand what I'm saying? You don't put it over whole numbers. You only put it over the decimal part that repeats. Okay? All right, look down at example 2. If they tell you to round it, look down at 2, y'all. if they tell you to round it like A, I'm gonna write it up here, 5.316. Which part's repeating?
6,
6. It says round it to 5 decimal places.
3, 1,
So
6.
let me write it to 5. I'm gonna have to write it. Now, if I'm rounding, listen, if I'm rounding to 5 decimal places, how many decimal places do I need to see? No.
4, 5.
If they want me to round it to 5, I'm gonna have to see 6. Because I'm gonna see the one after where I wanna go, right? So how many places do I have here? I've only got 3. Well, what's the next one?
3.
No? What part repeats?
6,
6. Now I've only got 4. I need another one.
6.
And I need another one. All right, now I can stop because they want me to write it to 5 decimal places, right? So I have to look at the one behind it, and that 6 tells me to do what?
Cross that.
Yeah, I'm going to get rid of the 6 and round this one to 7. Have y'all ever done that before? No? All right, let's write this one down. Write this one down. 25.405, and I want the 405 with the bar over it. Okay, they want you to round it to how many places? 5 places. Do we have 5 places?
No.
Well, that's underneath of it. Write it out to 5 places. What's the next one going to be?
4.
4, and then
Oh.
0. Good. So now we've got 5 places. But to round to 5 places, I need the 6th one to know how to round. So what's the next number going to be?
5.
5. Does 5 tell me to round up or down?
Up.
Up. So I'm going to drop off the 5 and change the 0 to what?
1.
1, and this is the answer. Okay? So this lesson, there's not a lot of work, but you're going to have to know the rule. Okay? You're going to have to know the rule to be able to do it. One more thing. Last thing in this lesson, they have you divide it out, which y'all know how to divide. Divide it out. If you do need help, you can contact me and I can help you with that. And then you have to put the bar up. Okay? We good? All right. Y'all did a great job. And Eli, you got your test?
No.
Oh, she did?
Mom sent it.
Oh,